Now, potential energy of a system of charges. See, we already discussed this thing. What is the concept of electric potential and electric potential energy? Now, electric potential energy of any charge at any point in the electric field, that is nothing but the total work done against the field to bring that charge q from infinity to that particular point. હવે જો આપણે કોઈ આખી સિસ્ટમની પોટેન્શિયલ એનર્જી આપણે ડિસાઇડ કરવી હોય તો શું કરવું પડે કે આપણે આખી સિસ્ટમની અંદર જેટલા ચાર્જીસ છે એ બધા ચાર્જીસની એસેમ્બલી તૈયાર કરવા માટે જે ટોટલ વર્ક ડન કરવું પડે એ કેલ્ક્યુલેટ કરવાનું અને એ ટોટલ વર્ક ડન to assemble that entire charge system will give you the potential energy of that particular system of charges. See, suppose we have a system of 3 charges, or we want to assemble a system of 3 charges. Okay. Now, we have to bring these 3 charges Q1, Q2 and Q3 one by one from infinity, and in that particular process we have to calculate the total work done against the field. Now see, very first we bring charge Q1 from infinity to point 1 as shown in the figure. Point 1, that is at the position R1 from the coordinate, origin of the coordinate system. તો ચાર્જ Q1 ને તમારે point 1 પાસે લઈ આવવા માટેનું જે ટોટલ વર્ક ડન છે ને એ 0 થશે. Why? ફિલ્ડ જ નથી. There is no field. Therefore, the work done to bring charge Q1 from infinity to point 1, 0. Clear? Any doubt in this one? Now, bring charge Q2 from infinity to point 2. But when we bring charge Q2 from infinity to point 2, at that time charge Q1 is already there. It implies that, in other words, we can say we are placing charge Q2 in the electric field of charge Q1. Okay? So here the total work done, that is potential at point 2. So potential of charge Q1 at point 2, that is, suppose V1. So the total work done, that is W2 equal to Q2 into V1, where V1, that is, as per equation KQ upon R, we can write KQ1 upon R12, where R12, that is the distance between Q1 and Q2. Clear? Then after, we can say, now the total work done to assemble a system of 2 charges Q1 and Q2, so that is W1 plus W2, and that work done will be stored in it in the form of potential energy. So we can write W1, that is equal to 0, and W2, that we calculated K Q1 Q2 upon R12. So simply we can say the potential energy of a system of 2 charges, that is K Q1 Q2 upon R12, that is the distance between those two charges. This one is similar to that the gravitational potential energy of a system of two masses, Gm1 m2 upon R12. Clear? Now here if Q1 Q2 is greater than 0, then we can say U, the potential energy is positive, and if Q1 Q2 is less than 0, means potential energy is negative. Now suppose here a third charge Q3 is brought at point 3 from infinity. Then total work done is how much? So work done, that is potential at point 3 into Q3. પણ હવે Q1 અને Q2 બે ચાર્જ હાજર છે અને તમે થર્ડ ને લાયા છો, તો Q1 નું પોટેન્શિયલ at point 3. So we can write here potential of charge Q1 at 3, that is V13. Then potential of charge Q2 at point 3, that is V23 into Q3. Now Q3 into potential of charge Q1 at point 3, that is KQ1 upon the distance between 1 and 3, that is KQ1 upon R13, plus potential due to charge Q2 at point 3, that is sorry, KQ2 upon R23, the distance between 2 and 3. So we can write now resultantly this work done, that is equal to KQ1 Q3 upon R13 plus KQ2 Q3 upon R23. Clear to all of you? So we can say the total work done to assemble the system of these three charges, that is W equal to W1 plus W2 plus W3. So that total work done is stored in it in the form of potential energy. Now W1, that is equal to 0. Then W2, that is KQ1 Q2 upon R12, and W3, that is KQ1 Q3 upon R13 plus KQ2 Q3 upon R23. And this one is stored in it in the form of potential energy. So now we can say the potential energy of the system of these three charges, that is U equal to KQ1 Q2 upon R12 plus KQ1 Q3 upon R13 plus KQ2 Q3 upon R23. In short, તમારે શું કરવાનું કે તમને ગમે તેટલા ચાર્જ વાળી સિસ્ટમ આપી હોય અને તમારે જો આખી સિસ્ટમની પોટેન્શિયલ એનર્જી ગણવાની હોય તો તમારે જેટલી પોસિબલ પેર્સ હોય 2 2 2 2 ચાર્જીસ વાળી એ બધી પેર્સ માટે પોટેન્શિયલ એનર્જી લખી ને એનું સમેશન લઈ લેવાનું. That will give you the resultant potential energy. What is Sama?